All right, so I'm going to be solving this question from the five fundamental questions in chapter 24. And the question is basically asking for the charges and the potential drops across every capacitor in the circuit. And one of the main things that we need to know in this question is that the capacitors can be in a series or in parallel. If capacitors happen to be in a series, then the charges are the same. And if capacitors are in parallel, then the voltage is the same. So now, in order to be able to solve this in an easy way, we find the equivalent capacitance to be able to work with all the capacitors at the same time and be able to compare them. So first we can, if we see the ones in parallel, we know that the equivalent capacitance is just to be able to find them in a parallel, we just add them up. And this is this right here. We go ahead and we add them up just like they are, right? So if we do that, we find that the equivalent capacitance of 1 and 3 is going to be equal to 4.0 times 10 to the negative 6. Okay, so now we have something looking like this because we already took care of the parallel. So all the capacitors are going to be in a series. We can go ahead and further take the equivalent capacitance and end up with something like this. And how do we do that? Well, we add 1 over, we know that 1 over the equivalent capacitance will be equals to the sum of 1 over C1 plus 1 over C4 and so on, right? So once we do that, we get this value right here, which is the total or the equivalent capacitance of the whole thing. And the equivalent capacitance is just the capacitance that is equivalent to the total value of the capacitors in that circuit. So if we have that, then we can use the voltage across the whole thing to be able to find the charges, because we know that the charges in the series are going to be equal. So we use the equation Q is equals to CV, or the capacitance times the voltage, which is was gotten from that equation. And then we get that the charge is 0.001 coulombs. And that is going to be for Q2, Q4, and the capacitance and the charge for the equivalent capacitance of 1 and 3. So now, if we're in a series, how can we find the voltage? Well, we just find the individual voltages for every single one of them using the same equation, just playing around with it, because if we know that capacitance is equals to the charge divided by the voltage, and we want to find the voltage, then the voltage is just the charge divided by the capacitance. So then the voltage across 2 would just be the charge 0.01 divided by in this case 1 point by the capacitance, which for the first one is 2.0 times 10 to the negative 6. It would be coulombs. And then for V4, it would be the same, coulombs divided by, but in this case would be 4 to the negative 6. And then for the voltage across the equivalents of 1 and 3, which is this one right here, still as an equivalent, then the voltage across that, knowing that the capacitance across that is 4.0 times 10 to the negative 6, we get the different voltages across. Remember, this is for the equivalent capacitance, so the equivalent voltage of both of them, but they're going to be the same. So we just find the value for that. All right. And that is the answer for this question in chapter 24.